Welcome to the Explainer. Today, we're tearing right into the mechanics of the human heart, basically going diagram by diagram to completely transform how you view the biological machine beating inside your chest. You know, we usually talk about the heart in super poetic or emotional terms, but for the next few minutes, I want you to look at it strictly the way an engineer would look at an absolute masterpiece of mechanical design. Okay, let's just dive straight into this. Right now, as you're listening to me, you have a pump in your chest that has literally never taken a single break your entire life. If you're an adult, that pump has likely beaten over 3 billion times. Think about that for a second. 3 billion. Most machines we build, they need constant maintenance, oil changes, downtime, you name it, but not this one. And honestly, despite relying on it every single second of every day, most of us have absolutely no clue how it actually works. So we're going to treat this explainer exactly like an engineering blueprint. We'll start by looking at the heart as the ultimate engine, then move inside to check out the 4 chambers. From there, we'll cover the one-way valve system, the electrical pacemaker, and finally, we'll wrap up with why your heart matters and some basic system maintenance. Let's get to it. All right, Section 1, the ultimate engine, 2 pumps working side by side. So physically, your heart is this super muscular organ, roughly the size of your fist, sitting just a bit left of center in your chest. It's the undisputed engine of your circulatory system, with one crucial job: pump blood to every single cell in your body. But here's the catch: it's not actually just one pump. It's 2 completely separate pumps bolted together, doing completely different jobs. The right side pump, that handles your oxygen-depleted blood. You can think of it as dark, tired blood coming back from feeding your body. It shoots that blood straight over to the lungs in what we call pulmonary circulation. Meanwhile, the left side pump is dealing with the good stuff: oxygen-rich blood, fresh and fully loaded from the lungs. Its job is to drive that blood out to your entire body, which is systemic circulation. Basically, 2 pumps, 1 unified engine block. Moving right along to Section 2, inside the 4 chambers. Let's look at the actual cylinders of this biological engine. To see how this dual pump action actually works, we gotta follow the journey of the blood through its internal cavities. Step 1, the tired blood flows into the right atrium through these 2 massive veins called the superior and inferior vena cava. Step 2, it drops down into the right ventricle, which gives it a squeeze and pumps it straight to the lungs for fresh oxygen. Step 3, that blood returns, fully oxygenated, right into the left atrium. And a quick aside here, this is a super fascinating fact. These are the only veins in your entire body that carry oxygenated blood. Pretty cool, right? Finally, step 4, that fresh blood drops down into the left ventricle. And this brings us to the absolute powerhouse of the whole operation. The left ventricle is built so differently than the rest of the heart. It's wildly muscular compared to the other chambers. Why? Well, the right side only has to kind of gently push blood next door to the lungs, but the left ventricle? It has to generate an incredible amount of mechanical force to blast that oxygen-rich blood through your aorta, which is the body's largest artery, and deliver it all the way from your brain all the way down to your toes. All right, Section 3, the one-way valve system. These are your mechanical doors. So with all that immense pressure and fluid just whipping around in there, how does the heart keep the blood from sloshing backwards? It relies on a highly specialized set of mechanical doors, or valves. There are 4 main gatekeepers you gotta know. First up, the tricuspid valve, sitting securely right between the right atrium and right ventricle. Then you've got the pulmonary valve guarding the exit out of the right ventricle. Over on the left side, we find the mitral valve between the left atrium and ventricle. And lastly, the aortic valve at that massive exit of the left ventricle. These 4 valves absolutely guarantee that once blood moves forward, there is no going back. They just snap shut, perfectly sealing the chamber behind the blood. But what's really interesting is what happens when this perfectly tuned machinery actually breaks down. Let's say a valve gets damaged or just doesn't close all the way. The blood doesn't seal perfectly and it creates turbulence. That turbulence creates a very distinct sound that we call a heart murmur. It is literally the sound of a mechanical leak, and doctors can actually hear that improper flow happening in real time just by putting a stethoscope on your chest. Let's shift gears to Section 4, the electrical pacemaker. Time to talk about the wiring. Okay, so we've got the fluid, we've got the plumbing, and we have the mechanical doors. But an engine needs spark plugs, right? It needs ignition. A heartbeat isn't just a random muscle spasm, it's a perfectly, exquisitely coordinated electrical signal. And that ignition starts in this tiny cluster of wiring called the SA node, or sinoatrial node. This is your heart's built-in natural pacemaker. It fires off a signal that spreads instantly across the upper chambers, causing them to contract and push the blood downward. But this is where the engineering gets just chef's kiss. As that signal moves down, it hits a secondary node called the AV node, and the AV node actually stalls. It purposefully delays that electrical signal for just a fraction of a second before sending it into the lower chambers. That microscopic delay is everything. It creates an exact rhythmic sequence. Relax, fill, contract, push. Relax, fill, contract, push. It's a completely perfect electrical dance. And to put that into perspective, that precise electrical cycle happens about 70 times every single minute. If you extrapolate that out, it means your internal wiring is firing that relax, fill, contract, push sequence over 100,000 times a day. 100,000 times, never skipping a beat. And that brings us to our final part, Section 5, Why Your Heart Matters. Let's talk system maintenance. We need to step back from the biology diagrams for a second and ground this in reality. Because knowing how your internal engine works isn't just about passing a science test. Understanding and maintaining this system could quite literally save your life. The terrifying truth we all have to acknowledge is that when this machine breaks down, the consequences are catastrophic. Heart disease is the #1 killer on the entire planet. Let that sink in. It takes more lives globally than cancer, more than car accidents, more than anything else. Basic system maintenance of this engine is absolutely non-negotiable. Which means you've got to know and deeply respect the warning signs of a failing engine. If you're feeling weird chest pressure, unexpected shortness of breath, or pain that radiates out to your arm or your jaw, that is your body's dashboard flashing a bright red warning light. You absolutely cannot ignore them. When you understand how incredible this machinery is, you realize you have a duty to protect it. Seriously, when you step back and look at the whole shebang, 4 chambers acting as dual pumps, 4 perfectly sealed mechanical valves, 1 highly synchronized electrical system, all running with 0 days off for decades on end. You quickly realize that you are walking around carrying the single most reliable machine ever created in the history of the world. So I'll leave you with this. Are you listening to your engine? I really hope you treat it with the respect an engineering marvel deserves. Thanks for joining me on this explainer. If you want to keep exploring the unbelievable biological machines inside your body with us, make sure you subscribe Surgeon Study Vault.